Hello everyone, here in this video we are talking about how a thermometer works, how it is designed actually. We know heat is a measure of, heat is a concept of energy, heat is a format of energy, and to measure this heat, hotness or coldness of body, we use temperature. As I told you earlier, heat is the cause and temperature is its effect. So, to measure this temperature, we use device called thermometers. How the thermometer works, let us try to understand that first. The first thing I want to tell you is, with rise in temperature, length of liquids, area of the liquids or volume of the liquids increases. We can choose a liquid, something like mercury, to measure the temperature. Why mercury? We have one point, like it has a high expansion coefficient. What's the meaning of high expansion coefficient is, even for a small change in temperature, expansion of the mercury is high, big enough to measure and experience. That's why we use mercury. So how do we do it? We take a kind of a cylindrical tube, we'll have a bulb at the bottom, and mercury is filled inside. And this bulb is kept in contact with the body whose temperature has to be measured. Then this mercury expands. If you notice, volume of the mercury increases, but the area of cross section of that tube is fixed, constant. So volume is area into length, that is constant. Length equal to constant by area is also a constant, that is also constant. So when volume increases, its its increase is proportional to the increase in the length. Thus we measure the increase in the length as a effect of increase in temperature. Let us say at 0 degree centigrade, length of mercury is L0. At 100 degree centigrade, length of mercury is L100. Then increase in the length L100 minus L0 is directly proportional to its initial length and also directly proportional to change in temperature. Combining these two, 100 minus 0, we can eliminate the proportionality by putting a constant alpha, where alpha is called expansion coefficient of that liquid, 100 minus 0. So alpha can be written like L100 minus L0 by L0 of 100 minus 0. This is quite possible that I can write the same equation at some other temperatures like LT minus L0 by L0 of 100 minus L0 of not 100, because the respective temperature here, the higher temperature is 100, here the higher temperature is T minus 0. So we got an equation like L100 minus L0 by L0 of 100 equal to LT minus L0 by L0 of T. Both of them are equal to alphas. So L0s can be cancelled. So I can write the value of the temperature as LT minus L0 by L100 minus L0 take this 100 to other side. So using this formula, I can measure temperature using a temperature scale. That can be labeled on the top, and so we can observe it carefully, easily. And here I want to tell you that it's not only the length that varies with respect to the rise of the temperature, but there are some other parameters, like, for example, if gases are used to measure instead of liquid, we can write the temperature as directly proportional to change in temperature is directly proportional to change in pressure at constant volume. Basing on that, we can write the temperature as Pt minus P0 by P100 minus P0 multiplied by 100, depending on how do we use the scale. Or we can say at constant pressure, volume is also directly proportional to temperature. So we can measure the temperature as Vt minus V0 by V100 minus V0 of 100. Or we can also say for certain materials whose temperature coefficient is positive, increase in the temperature is directly proportional to change in resistance. So we can measure using, say, pressure thermometers, volume thermometers, resistance thermometers. Anything can be used to measure the temperature of a body as RT minus R0 by R100 minus R0 of 100. Thus, we have different ways of measuring temperature. What are the different ways? It could be mercury thermometer, it could be gas thermometers with volume kept constant or pressure kept constant, or it can be resistance thermometers. Any of these things can be used, and the concept that we use in all these cases is quite simply that particular parameter, whatever that particular parameter, is proportionate to change in temperature. Taking that into consideration, we can use any of the scales, we can use any of the methods to measure the temperature of a body. That's it. Thank you.